welcome everyone to our session.
So let's reintroduce ourselves. So my name is Oleg Zhurakousky, and I'm the lead for Spring Cloud Function and Spring Cloud Stream projects within the Spring Cloud portfolio. And
yeah, I work with the Spring Cloud team mostly on Spring Cloud Load Balancer, but also OpenFane, Spring Cloud Netflix, Spring Cloud Contract, and recently also on RSocket HTTP Bridge.
So obviously, we're going to be talking about what's new in Spring Cloud. So there's going to be a lot of forward-looking statements, or some of them. So some things we're experimenting, some things are already part of the framework, some things will make it into the final stages of various different projects, some may not. So basically, the mandatory legal slide about the fact that we may not be, everything that we may say here may not at the end make the cut.
Also, we will probably, well, there have been a lot of new things, and especially since Spring I/O in 2019, there have been a lot of things, so we have just made our own selection of what we think is interesting and exciting.
Yeah, actually, it was kind of interesting to, like, Olga and I sat down yesterday, and we were discussing, like, what actually is new, because typically we have this annual cycles of these type of conferences, so it's much easier to distinguish what is new, what is not. But we haven't seen each other face-to-face in, what, 3 years, so to speak? So it's like a lot of things came and went. And so is it new? Is it not new? So forgive us if we're going to present something that you already know. But if not, then you'll discover something new.
So one of the new things that we have introduced is Spring Cloud Square. And it is actually Spring Boot and Spring Cloud integration and support for retrofit and for OkHttp. First of all, we provide WebClient support for retrofit. We've been supporting Fane as Spring Cloud, and we've had our integration for a long time, but that did not allow for non-blocking support and did not allow for using WebClient underneath. And we wanted to have this available, so a declarative client where you could use WebClient underneath and non-blocking stacks. And we found out that it would be not very difficult to implement as a retrofit integration, so we have done just that. You will see the code in a moment. Just to let you know, we have provided their auto configurations as well, so we will create all the necessary beans for you, and it's both for retrofit and OkHttp. We also are providing load balancing under the hood, and we have also added tracing for OkHttp to that project as a Spring Cloud Sleuth integration. And unlike in Fane, where you could reuse Spring MVC annotations, with Spring Cloud Square, we only allow retrofit annotations. So there's a story when it comes to bringing this project in. This project has been in our incubator for quite a long time. However, we wanted to bring it out and add it because there was a lot of demand for the non-blocking declarative clients. And we've talked to our larger Spring team. And what appears was that there was actually an interest to create something similar in Spring. And so it was done. Rosen and I have did an entire session, all that yesterday. But I will still show you some snippets of this here. So as for Spring Cloud 2022, that will be the recommended solution and integration. We are going to maintain Spring Cloud Square throughout 2021. And for that line, it is the recommended non-blocking declarative client.
So is it that one of those unique cases where you're presenting something new that's already sort of becoming outdated because the support for Square is going to be coming within Spring Core per se?
Yeah, so it's still new, and if you're not going to switch to 2022 in a long time, you can use it. And if you will be switching, then we will see in a moment what will be there. So just to show you what this Spring Cloud Square retrofit client looks like, we are using the retrofit annotation, so that what is like below will look like any retrofit client. However, what we are providing is this retrofit client annotation on top. This will be responsible for auto configuration, but also if you pass a service ID, like the gateway we have here, it will load balance for you under the hood. And yeah, that is getting replaced, and that's super exciting, with Spring Interface Clients. We think it is exciting because we've been getting requests and issues to introduce this kind of thing for a long time in Spring Framework. So this is going to be, and actually already is, you can already get a milestone with it, so give it a try. A first-class solution in Framework, and this will replace the existing third-party integrations. So Spring Cloud Square, and then when it comes to Spring Cloud OpenFane, we will be marking it as feature complete in 2022, Spring Cloud release train. So, yeah, you can already see the HTTP Spring Interface Client in the milestones, and what we provide there is the HTTP Service Proxy Factory that you can easily instantiate as a bin, and you can then create your own clients. And we provide the HTTP Exchange annotation, which is going to be different from the request mappings that you have on the controller side, on the server side, but a lot of other annotations that you are used to, like path variable, request body, request header, and so on, will be used in both scenarios, so also in the interface client. And we will be also supporting HTTP method. We will be supporting both blocking and non-blocking modes. Right now, it's created with WebClient support, but this can be later broadened. We will be also later adding a multi-part support. And later on, in future milestones, we are planning to add a similar interface client for RSocket as well. So this is just a snippet of the new interface client. If you're interested in more details, you can see the recording of the yesterday's session. But yeah, it's very, very simple. You just have a GET exchange, and you annotate all the arguments. And for those of you who have not used declarative clients, you can just then create an instance of this service and just run the execute method, and then actual HTTP call will be made for you underneath. And you can also see an example with post and with URL form encoded.
And are we going to see a little sample of it running today?
We are going to be seeing Square, so
Okay.
we will see that declarative client, because the other client was already showcased yesterday.
Okay, perfect.
Also, there are big changes happening throughout all our stack when it comes to observability. Spring Cloud had for a long time the project called Spring Cloud Sleuth that provided tracing support, and this will be now changing. So from Spring Cloud 2022, you will not be having Spring Cloud Sleuth anymore. We will only be maintaining this throughout 2021, and we will be moving to, with the same functionality, we will be moving to Micrometer. So in Micrometer 1.10, you can get tracing support with the new observation API. You get the observation and observation handler classes that we will see shortly, and all the tracing will be set up for you by Spring Boot 3 and by the projects. And yeah, Spring Cloud Sleuth will be only maintained throughout 2021. So this is the Micrometer observation API. If any one of you has ever used the timer API, it's very similar, as you can see. You just create an observation registry, same as you would create a timer registry. You can have a context where you can pass your own data, and then you just run the observe method, and within that method, you call whichever code you want to be running the observation for. And the handler also allows you to interact with the context throughout very easy callback methods. And another exciting thing is RSocket. So this is not as new, but I keep talking about it at conferences because we think it does not have still the adoption it deserves. It is really a fantastic protocol. And I can say this in an semi-objective way because I have not in any way contributed to the creation of this protocol. So yeah, I think it's fantastic.
So if I were to give you an option, gRPC or RSocket, what would the answer be?
It would be RSocket.
Okay.
Yeah, please give it a try if you have not. So what it does is to bring reactive stream semantics onto protocol level. So all the communication is modeled as message-driven asynchronous streams over a single connection, and it never synchronously blocks the communication. So once the connection is made, there is no more client-server distinction anymore. It can be sent both ways. We have 4 modes, so you can just fire a message and forget about it, no response needed. You still have your standard request and response, but you also have the models that are better for what we do these days with many applications. So you can have a request, but receive a stream in response, or you can have a channel where both parts keep sending streams of messages.
Awesome.
And it's fully binary, so we are no longer trying to talk in the internet network with text. It does offer the flow control, so you have back pressure, you can request and you have leasing semantics that can allow you also to signal your capacity through frames. And it supports various protocols, so you can use TCP, you can use it on top of WebSockets and Arian. When it comes to Quick, in the documentation, we can read that Quick, it's not enough open yet and enough exposed for them to provide this integration, but it is possible that if that changes in future, they will do it. Spring already offers quite a lot of support for RSocket through Spring messaging. We have the RSocket requester Fluent API. As you can see, it's super easy to create a requester object, and you can set it up, for example, providing the protocol or the host port, other necessary data. And then making requests is also very simple. You just send some payload in the data, for example, and then you can retrieve a flags. The return times will be depending on the mode that you want to be using. And you also get message mapping for usual communication and connect mapping for the setups, annotated responders. So this is very similar to all your annotated Spring controllers that you might be used to. This is what it looks like, not much more complex. And it was interesting, even though we're skipping a little bit ahead, we're also, I'll be talking later on about Spring Cloud Function and RSocket support that was added to Spring Cloud Function, which for you, the benefit is that all you would need to write is just a function, throw a dependency to the POM, and not put any annotations. All of a sudden, your function will become a RSocket endpoint. Yeah, and then we also have a metadata extractor so that you can communicate, like you can work much easier with the metadata and just get it in an easy-to-use format. For example, the JSON map that we are doing here. And Spring Cloud team, along with Reactor team, has also started already some time ago working on something that would bring the highly popular gateway model to RSocket. And that is the RSocket broker. It is a specialized distributed broker for RSocket, and it takes care of often concerns that we often have, such as service discovery, load balancing, fault tolerance, and security in one simple model. So it is a distributed broker because, as you see, while services can register with a broker, the broker instances can also connect with each other. And in this way, we can perform all the routing and also load balancing underneath.
Would that present a performance issue if there's too many brokers? Or?
If we had such a stack with HTTP, I would be worried. But RSocket is performant enough for that not to really pose an issue, which you can try. It's all already available.
Cool.
And we, however, often might have this problem that we have all this stack and all our applications and maybe some external clients that we cannot influence running with HTTP and sending HTTP requests. And it might be difficult for us to start introducing a new protocol and a different broker instead of our gateway that we always used. So we have thought of a solution to provide this kind of seamless routing of HTTP requests through RSocket broker to RSocket services. And that would work with a simple post. And this is already available also. It's called RSocket HTTP Bridge. It is available under the RSocket broker org, and we will also see it all in the demo. You can send post requests like the one you can see in this screen. And what we will do is we will use the service ID to get the information about which service you are trying to connect. So the RSocket service through the broker. We will use the RSocket endpoint ID to know exactly to which endpoint this goes. This one does not have one more segment that it could have, which would go before service ID, where you would specify the RSocket mode, so request response, request stream, and so on. It doesn't have it because you can also configure default one and then use it for your requests. And we support byte arrays, but also payload decoding. We support concepts that the broker uses, so you can pass tags as headers. We also support the broker's well-known keys. And we provide very easy Spring Cloud Gateway integration, and you will see it in a moment. It is just a starter and a very simple route.
So basically, you're saying that if I have a bunch of different functionalities exposed via RSocket, and I want to expose them via over HTTP, I don't need to write my own HTTP client and use RSocket API to call it. We can just declaratively. You
don't need to write your own adapter, or you don't need to use the client underneath if you cannot, or are not ready to change all your infrastructure.
Problem I did yesterday, but I should have known.
Okay. Will you show the code?
I will.
Yeah,
all right,
let's
so,
see in action.
So basically, we needed to, Olga and I needed to negotiate how to do the demo because she is Linux, I'm Mac, she is IntelliJ, I'm Eclipse. So we really have a dysfunctional relationship, but we'll try. Okay, Olga, what do you want me to do?
Let's first see and run the loan service application. So we will have two apps. The loan service app, we will be trying to register a new loan. And then we will have a verification app. We will be trying to send a request, and the verification app will let us know if that is OK, or if the customer is a fraud, or some other reason to reject this loan. And if some of you have seen my previous presentations and are asking why loans again, well, I'm not very imaginative when it comes to the domain, so most of the examples are loans, but the underlying tech will be different.
Likes to borrow money, that's all.
Yeah.
All right, so we got application. There's not much interesting in it, which is like a typical boot application, you know, just an application, and that's it. So what?
Yeah, let's see the entry point to the application. So our loan application controller.
Okay, that's has
and we will be posting at apply. And
okay.
what will be called underneath is this create loan method, which will take us to the client call. So we are going to be calling this retrofit.
Oh, that's what you were showing earlier.
Yeah, exactly. And as you see, we have the customer service ID. So this will do the load balancing for us and find any services with the customer service ID. And we are going, yeah, let's start it. And let's also see the POM. So as you see, again, very simple POM. We are getting the load balancer, and we are getting also the retrofit web client. So this is the one which allows you to use web client underneath. Yeah, and then we can show our server app.
And which one do I start?
The legacy one. So this one has HTTP.
So this is a typical legacy application, which is like a typical HTTP legacy application, which has services, which has controllers and everything. So you can see those of you who's done Spring Cloud Web, Spring Web, this code should look very familiar to you. Like I said, there's nothing. It's like a starting point, just a regular existing app. And what Olga is going to show to you how this particular app could still be interacted with various different HTTP declarative clients.
Yeah, and we have the verify endpoint. So there we will get the verification. It's very simple. Basically, if you first call register and register the client, it will be verified as positive. And if not, it will be verified as fraud. So we can run this application and see it work. And then we will tweak this application to become more functional and then to become in RSocket app.
All right.
And throughout all these changes in the server app, we will not be changing the client application. Yeah.
I'm just trying to make it look.
Is it visible?
Well, I'm working on it.
I think it is. Can you see the font? Is it fine?
Well, there's going to be HTTP command. So which one are we doing?
With the application, yeah. Yes, so it's rejected because
It's
the client was not registered, and
Yeah,
then we
so
can
we're gonna,
register the
so basically,
client.
the loan application, the JSON is, there's only like a simple JSON for first name, last name, and an ID.
Yeah, we can show you
We can
the
show it to
JSON
you, but
in a
there's
moment.
nothing there. So we're gonna do the registration, so the registration succeeded, right? And now I can go back to,
Yeah,
and
so now we
so-
can kill this legacy app. We don't want to be using it anymore, and we will run the new functional app. And will
okay,
you
so
talk about it?
the new functional app is like, let me talk a little bit. So again, I specifically mentioned that we emulated sort of the legacy app where everything is congested into the same thing, because as you see, the verification app a controller, we had this post mapping annotations, we had a controller annotation. But what I want you to look at as a kind of a preset for what I'm going to be talking about in a few minutes, which is a functional app, right? So again, Spring Boot application, and all you see here is that, so first of all, one thing I did here is I've extracted all the business functional code like into a separate library. And I'm not going to show it to you, basically just a plain code, but I put it into this customer library, right? And then I add it as a dependency. And then all I need to do is in Spring application create two beans of type function, which is customer service and verification service, right? They're all functions, and I can see,
And we will be also later linking this code in the slides, so you
right,
can take a
right. So basically,
closer
it's a function, and the point is that you define as being as a function. There's no other notation, no post mapping, no controller, nothing. And the only difference is that you'll see here is that there is also not here, sorry. In the application itself, if you look at the POM, there is a Spring Cloud function web dependency, and with Spring Boot. Obviously, you by now know that dependency is not just a library dependency. Most of the dependencies, they're auto-configuration dependencies. So with the dependency added to the POM, you're effectively bringing some auto-configuration that will do something. And what the Spring Cloud Function Web will do is that it will expose the function as a REST endpoints, right? With the function name being the path. So at this point of time, the benefit here is obvious, that you just have a function, you just write a function, you don't have to worry about web controls or anything else. You just stick a dependency in the POM, all of a sudden you have yourself a REST endpoint. And I'm going to start this.
Have we killed the other one?
Yeah, we did. So I'm going to start this application, and you know, we will expect basically the same result. So we register the customer,
and running the same client.
So running the same client against the different application. But this one is sort of a bit more modern because it gives us a bit of a flexibility, because think about, and again, I'm going to be talking about it later on, but think about the fact that, again, you wrote a function, you can unit test it outside of the specific context of execution, in this case, web or RSocket or whatever, and then by simply adding a dependency, you expose this function, you make it being triggered by either as a REST, as a RSocket, gRPC, or anything else. All right, Olga?
Yeah, and do I think correctly that we can take the exact same code and just change the starter and we will get an RSocket application?
Yes, in fact, we are going to be doing it, right?
So let's kill this one.
We're going to kill this one. And so we have another application here, which is a customer functional RSocket. As you can see, so I want you to compare. So right now, what you're looking at is our web application, the new functional one, right? And I'm going to open up the RSocket one, and what you're going to see is absolutely nothing different here. It's absolutely identical to this. What is different is what's in the POM, and in the POM here, we have Spring Cloud Function RSocket instead of Spring Cloud Function Web. And all of a sudden, these functions are exposed as RSocket endpoints.
Yeah, so let's run this one, and now we don't have anymore an HTTP server. We now have an RSocket server,
Okay, so
and we will be connecting to it with the same client.
All right, so we started that one. Oh, that's your debug statements.
Yeah, I just have added the log statement.
All right, so what do I do next?
I'm sorry. Yeah, so we can run, we have the app running, or sorry, let's still switch this app off, and let's first show the broker. So let's disconnect this. Let's show the broker and run the broker. So they will be able to register.
RSocket broker application, again, there's nothing interesting in the application
nothing.
itself.
The only thing you are interested in is this is the broker app, so you will only have a starter, which we'll see in a moment, and a very minimal setup. That's all the setup. Of course, you can have some more custom things, but basically you were configuring the cluster, and we were configuring the ID, and also the appropriate HTTP data. And when you see, you can get just this RSocket broker Spring dependency, and you are done. So let's run the broker. Let's run that RSocket app again so it can register. The one called RSocket, yeah. And we have our gateway. So we might have been using it for HTTP apps. And
again,
as you see, nothing to it. What's important is the POM.
Gateway POM, right?
Yeah, the gateway POM. So yeah, we have the gateway starter, but to it we have also added the RSocket broker HTTP bridge dependency. In the meantime, we see that something has registered. And yeah, and what we have also done is configured a very simple route. Let's see application YAML.
For the gateway?
Yeah, for the gateway.
Oh, here we go.
So yeah, this is basically for our RSocket bridge. We configure that any requests that will be coming with the verified path should be sent over to this RSocket application that we have. So let's run this as well. And yeah, once it has registered, we should be able to do the exact same calls.
And now we're talking basically over RSocket, right?
Yeah, we are talking
over
about
HTTP
we have
and
not
RSocket.
changed the client. And here we had Square client, but we could also have had the new Spring interface client.
That's nice.
Yeah. OK, so I think we are done with this part of the demo, unless you still want to show something in this.
Not really. What do we have? 20 minutes. Perfect. OK, so
let's go back to the presentation.
Yeah.
We've done the demo, and then Spring Native is another one, like observability, one of these concerns throughout the entire Spring stack. And as many of you might know, it introduces support for GraalVM native images in Spring. And some of you might have used the Spring Native project, which was under the experimental projects org, and there was our initial support for it. However, now you will not need to do this anymore. The support is moving over to Spring 6 and the underlying projects. And this provides the compatibility for GraalVM, native configuration files, and the fantastic AOT plugin that is doing ahead-of-time transformations to make the code much more performant. And our colleagues that are working on it have been doing some talk on the keynote, and will be also doing more talks, so go and see this. And obviously, Spring Cloud also has to work with this new native initiative. So we already have quite a lot of supported starters. You can already try, go and build native images with them, and it will work. And we are planning to add support for others. And as you have seen, we had Spring Cloud Function among the supported ones. Do you want to talk more about this?
Yeah, so I think the Olga's part is done. So let's talk about Spring Cloud Function. So for those of you who, some of you may actually know, I mean, it's hard to do the show of hands because I see just a dark room. I now understand why the rock stars wear the glasses, because the spotlight is a bit distracting. But anyway, so for those of you who may know Spring Cloud Function, Spring Cloud Function is a framework that basically promotes implementation of business logic as Java functions, so supplier, function, consumer. And the reason why I like this approach is because I want to ask this rhetorical question, and I want you to think about it. Think about a requirement of a past, current, or future that you cannot map to either supplier, function, or consumer. In other words, is there anything that you need to do that cannot be implemented as function, as supplier, or as a consumer? To me, the answer is no, right? Which means that anything you do could be represented as function, supplier, or consumer. If that's the case, you already see a couple of benefits of it. And the main benefit is that giving the very robust structure of these interfaces, a very simple structure of these interfaces, we can now create this thing called adapters that could say, listen, you have a function, but you want to make it a REST endpoint. I can do it declaratively by simply providing a little bit of code around it, and you can just benefit from it. You want to make it RSocket, you want to expose this function over RSocket or gRPC, or make your AWS Lambda as still implemented as pure Java functions, go ahead, you can do that. The benefit of it is that you don't even need Spring for that, because what you're implementing is just a plain Java 8 function. Okay? So what else Spring Cloud Function does in terms of additional things, like function composition, right? So you say, well, function composition comes with Java functions. Well, yes, it does, but it's only function and function. What if you want to add function and consumer, or supplier and a function, or supplier and a consumer? So we provide these additional things. Or what if you want to add functions that aren't composable in terms of the typing compatibility, right? Well, because we provide transparent type conversion, we can compose function that outputs the string into a function that inputs, for example, a person, right? So, and Spring Cloud Function provides the type converters that will take care of it for you. And if we can't, then you can add your own type converter as an extension model. So POJA function, basically the concept of a duck typing. If it smells like a function, if it quacks like a function, it's a function, right? So in other words, if something doesn't implement a function, but it follows the pattern, follows the convention, we'll treat it as a function. Reactive support. So you can either an imperative function or reactive function will support both. And you can actually compose reactive with imperative, imperative with reactive. So again, you can break out your complex problem in a lot of simplicities and then reassemble it with function composition. Deployment of a package function, it's basically the ability to deploy the function and use it kind of within a container. And obviously adapters that I mentioned of a serverless platform. So the demo, I'm going to skip this mini demo because we already, I have 16 minutes. Actually, yeah, I'll skip it because I'll show it to you as part of just a little introduction demo. So Spring Cloud Function adapters. So this is kind of the breadth of the main purpose of this project is to introduce these various different adapters that allow you to expose function as provide various different trigger mechanisms for functions. So you want to write AWS Lambda, you can write your handlers, of course, using AWS API, or you can just simply write Java function and add our dependency to it, package it, deploy it, and we'll see it in a few minutes. HTTP, you already saw the HTTP. Well, you haven't. You've seen gRPC part, right? Actually, we've seen HTTP part as well already. I'll show it to you again. RSocket, there was a lot of talk about RSocket, gRPC today.
Oleg, let me ask you, which one do you prefer, gRPC or RSocket?
I'm a framework developer, so I support both. I have no preference. I'm trying to be very political about this.
Oh, really? Okay.
I mean, in all fairness,
yeah, but
I may probably lean on the side of RSocket, but you can't ignore gRPC. It's out there. It's popular. People are using it. So.
Yeah, it's also good. It just
yeah.
it's fun, but what we want to tell you is just please give RSocket a try.
Yes.
While gRPC is great, we feel RSocket is very underrated. So yeah.
Exactly. Cloud event. There's a lot of hype around Cloud event. To me, I wrote this series of blog posts, Cloud Events in Spring Part 1 and Part 2. To me, Cloud Event is basically a carrier of a data, so it's a message. It contains the payload and headers. So again, we support Cloud Event. We support Cloud Event as part of the within the concept of messaging. I would suggest for those of you who are interested, you can read the 2 series blog post. But we also support provide support for Cloud Event SDK, in other words, the SDK that is not provided by us, the Java SDK provided by Cloud Events. So again, it's something that was sort of requested by the community, and I think Mauricio is going to be talking about this in Knative presentation around 11:30. So going back to the slides. So gRPC. So let's talk a little bit about gRPC support within Spring Cloud Functions. So, and especially in the context of messaging. So we provide gRPC support in Spring Cloud Function. What does this mean? You probably already guess. It's an ability to expose function as gRPC endpoint, right? So we support 2 modes of operation, client and server. So 4 interaction modes, request reply, server, client, bidirectional streaming. So the way we decided to do it, how do you provide gRPC support when gRPC kind of, it's all about generating a protobuf and then reusing it, right? So, well, what we initially did is created basically, I'm a big fan of message. I am one of the regional developer of Spring Integration Framework, and this whole initiative about messages framework that was built on top of enterprise integration patterns. And so I'm a big fan of message because it's a very simple structure that allows you to pretty much carry anything, and it's very easy to relate to because it's like an envelope with a letter inside of it, right? So it contains the payload and it contains some meta information. So what we did is say, listen, if you embrace this notion of a message, then you don't need to generate and regenerate the protobufs. We already provide the service for you as well as the protobuf, which you see on the screen. Is basically, we call it gRPC Spring message, but it's really a structure that represents a message, which is basically has 2 fields, payload and headers.
So right? The user doesn't need to create all these.
So the user doesn't need to create. However, what if that is something that you wanted to do, right? I mean, we can't claim that we support gRPC without supporting fully gRPC, let's say, features and functionality. So yes, we do provide pluggable protobuf extensions, and I'll show it to you right now. So let me kill all the Olga's demos. There's just a lot of them. Okay, so we're good. All right, gRPC. So you guys see the code. So here's an example of what I was showing before. So I'm just showing you one of the test case from the framework. So you can look at the sample configuration consists of nothing but functions, and I might as well stop showing it because there is really nothing interesting there. And the real interest is that basically we have this gRPC utils class that we provided for you just as a convenience. You don't really need to use it. But the point is that you create a message and you simply send the message and you receive the message. I mean, as a request reply, for example, you can do, there's different methods you can see. There's a request reply, request by streaming, and so on. So you can do a variety of different things, but the point is that you can send a message and basically interact over a gRPC using a simple Spring message. The other benefit about embracing the messaging is because by doing so, you immediately integrate it with quite a few of Spring frameworks because while message started in Spring Integration Framework, it eventually trickled and moved its way into the Spring Core Spring Messaging module. So now a lot of the frameworks depend on Spring Message within Spring Web and other in pure RSocket. So by embracing it, you effectively becoming quite immediately integrated with a lot of the Spring stack. Okay, so but what if you, like I said, speaking of both, hitting like 2 birds with 1 stone, a Cloud Event and our gRPC. So in this particular case, we're dealing with a Cloud Event object, which is actually not our object. This is a Cloud Event that's coming from Java SDK provided by Cloud Events. And so they also provide the gRPC protobuf for it. So in this case, can we use their protobuf? And the answer is yes, we can. And basically, we needed to, the documentation provides explanation about this, but all you need to do is provide a message converter and event handler for it and add it as a dependency to your POM. And next thing you know, you actually use gRPC support and with custom protobufs, and it still works. While the function remains the same, just a pure function that takes the cloud event or takes the message. Doesn't really matter. Okay, so what else? So RSocket. Well, we already saw, so we could probably skip the demo because we already saw the RSocket part. We already saw RSocket part today working within Olga's demos, which is basically the ability to expose function as RSocket. And like I said, I want to point out one thing is that, again, like the previous presenter, Lars, and Olga was showing the message mapping annotations that you can use with the support provided by Spring RSocket. But if all you care about is providing functionality and just invoking it over RSocket, you don't even need that. You can simply write a function, add Spring Cloud function RSocket as a dependency, and it will just work. All right, AWS Lambda. So it's one of my sort of passion. I work a lot with the AWS Lambda engineering team. So again, we provide ability to write a Java function and deploy it into AWS Lambda basically deploy it on AWS as AWS Lambda. Right, so we support many different event types as SNS, SQS, Kinesis. I mean, there is a whole list of different event types that we support. A custom runtime. So in other words, if any of the runtimes within the AWS are not suited for you, we support, or you want to run on some, for example, unsupported JDK. Like until recently, JDK 11 was not supported, so a custom runtime was an option. But for example, if you want to do the 17 or something like that, right? So Graal VM support via Spring Native, and that's really kind of what I wanted to show you. So obviously, to show Graal VM support on Spring, like if I try to build right now, so as fast as everything else comes to native, building native is anything but fast, right? So so that's kind of
although it's also been improved over the years. Now it's much better than
it is,
before.
but I'm not going to take a chance with 5 minutes left to be building a native
and
image
also
right
have
now.
everyone just staring at the build logs.
Yeah, exactly. So, but basically the application I wanted to show it to you, again, very simple. So as I said, Spring Boot applications are extremely boring applications to look at because there is really nothing. They all look the same, just a Spring Boot application. So in this case, we have a function. In this case, we declare this function as a component. So we could have declared it as a bean inside, but we declare it as a component. And this function is a bit more interesting simply because it doesn't take your rudimentary string. It takes the person. So that immediately shows you the type conversion that will happen automatically. So in other words, we'll be sending a JSON string, but it's going to be converted, right? So and a person object is just a very simple domain object. And what I'm going to show is, so I have pre-deployed. So here's the uppercase custom function. This is the function that's being deployed. And
it's built as a native image, yeah?
That's a built as a native image. And so I'm just going to, well, I bet you can't see what I'm typing, but I'm just typing name Olga. And I'm going to run it. And here we go. Hi, Olga. So we got ourselves, so the function has been deployed as a native image on AWS. And again, you can take this function, for example, there's a Spring Cloud, Spring Native experimental project on GitHub. Just Google Spring Native GitHub. And there's a samples directory, and there's a within a sample directory, the project called custom function AWS. There's a bunch of different samples.
Also other cloud project samples
Yeah.
are in the same repository.
Exactly.
Run them as
And
native images with scripts.
Right, and some of them have, well, they all have scripts, and some of them have like in this particular one, it has a README file that tells you step by step what you need to do to build it, deploy it, and so on and so forth.
And have it running in Lambda, yeah?
Yeah, and both for Linux and Mac users.
Thank you.
Okay, last but not least, where are we? So event streaming, so I have about 3 minutes. So basically, event stream processing is a practice of taking action in a series of data points that originate from a system that continuously creates data. We kind of stole this definition from a Hazelcast, because I like it, I agree with it. So in order to enable event stream processing, we have a framework called Spring Cloud Stream, which technically is just another adapter because for Spring Cloud Function, because the main programming model is Spring Cloud Function. So you want to write a message handler, what do? Just write a function, once again, right? And we provide a framework that does this for you, right? So basically, it connects, we provide binders, the concept that allows you this function to be connected to a variety of different message broker, Kafka, Rabbit, Kinesis, Solus, MQTT. There's 3 binders that we support, and there is a bunch of community binders that are supported by the community themselves. So some of the core features is partitioning, consumer groups, message headers. It's, again, message-centric, so again, there's just our love for messages. And as I already mentioned, Spring Cloud Function is a programming model. Now, in terms of what's new, again, it was very difficult to determine what's new because of the fact that so much time went by. But the native support, so obviously Spring Cloud Function and Spring Cloud Stream are both fully capable native, including the AOT support that Stefan and Brian are going to be talking about later on today. StreamBridge. StreamBridge is a very interesting component, which I'll probably show to you in a second. Which is, gives you ability to bridge non-Spring Cloud Stream application with Stream application. For example, you have a REST endpoint and you want to enter the world of Stream. You can just inject StreamBridge and send data, and it will create the destination dynamically for you. So the monorepo, I mean, for those of you who follow the project, we used to have separate repositories for binders. Now everything is into a single repository, which obviously has no runtime implications, but for us as maintainers, it's a great, simplifies things a lot. With 4.0, we're having a true reactive Kafka binder. Earlier I mentioned that we support reactive API, but don't mistake API with the true reactive features, right? So in other words, we had a standard binders based on the message handlers, and we provide sort of a bridge to reactive API. That means that there's still no support for back pressure and all these reactive features. Now, with this binder, you'll have that full support for all these different reactive features. And finally, for those of you, again, who know the previous installments of Spring Cloud Stream, we had this annotation-based programming model with Stream Listener, input, output, and all these other things.
Yeah, we'll have to do that.
Gone. So basically, just functional-based programming model, and no more orientation-based. So in other words, your application stays pure as just the beans, and then you manage it with pumps, right? So one last demo, which is a very simple one. So I call it demo stream application, but it's kind of powerful in such a way that I'm going to start it. It has a function uppercase, right? But what I wanted to show you is I just typed uppercase / Oleg, and all of a sudden, and entered HTTP because this function was exposed as a HTTP endpoint. Why? Because in my demo, like I said before, I added dependencies in Spring Cloud Function Web. But here's what's interesting. I'm not even shutting down the app. I'm going to the Rabbit console, and you can see again, all of a sudden there's uppercase in, uppercase out, bindings were created, and now I can send a message, say, hello, Olga, and publish message, and we look at the console, so we see both from HTTP and from streaming. So all of a sudden, this one function, because of just the two dependencies, became both HTTP REST endpoint and message handler.
Yeah.
So I think, Olga, we're done.
Yeah.
We are done.
All the resources can be found in slides.
Yeah.
And we will be here in the lobby. Please feel free to reach out to us if you have any questions, comments, requests. Yeah. Thank you very much.
Prepared. Thank you, guys.